Hello. Java Chapter 7, looking at the lesson plan. And there's some sample code I'd like you to review, found on pages 250 through 254. It says self-discipline, but I did share the code with you via email. So check your .live account. You should have source code, and it's a complete program. It's a complete solution. Figure 7-7 and figure 7-8. Now we're going to discuss both of these programs so you can copy and paste that file into your project folder in NetBeans and run the program as well. So we're going to start with figure 7.7. Figure 7.7, roll die. And that is on page 253. Die rolling program using arrays instead of a switch. Now we're going to import java.security.secure random. We're going to generate some secure random numbers. Our class, public class roll die, and our end class. Public static void main, begin main, and end main. Secure random random numbers is a reference pointing to a secure random object. Our variable name random numbers equals new random secure random can be generated for us. We're declaring an integer array by the name of frequency. It's a reference to an integer array in primary memory. It equals a new int array with 7 elements. So we're declaring frequency as a pointer or a reference to an integer array, and the integer array has a element sub 0, index 1, index 2, index 3, four, index 5, index 6. This is an integer array, so it's going to store integers. And with our 7 compartments, remember that when you declare an array, we always begin with the 0th element. 0, 1, 2, 3, 4, 5, 6. That gives us 7 compartments. 1, 2, 3, 4, 5, 6, 7. 0 through 6 gives us 7 compartments. Your indexes have to be ordinal, not real. An index is not 1.275. And with an array, we're storing a single reference to a single array compartment where the 0th index is pointing to an integer. Index 1 stores and contains and points to an integer, and so on. So with our integer array declaration, int, notice that's the angle brackets, declaring that frequency will be an array reference pointing to an integer array. It equals new. We are assigning that new array now. It's an integer array with 7 compartments, and that would be indexed 0 through 6. Next, we're going to roll the die 6 million times. Use die value as frequency index. So we're going to skip or ignore our 0th compartment for logical reasons. It's logical to do so because our face of our dice, we have a face 1, face 2, a face value of 3, a face value of 4, a face value of 5, and a face value of 6. So logically, we're going to think of our face value and the number of times that that face value was rolled on our die will be the frequency or the count for face value 1 out of 6 million rolls. So we're going to simulate rolling the dice 6 million times. For int roll equals 1, while roll is less than or equal to 6 million, we're going to increment the roll at the end of each 4 iteration. So at this point, roll is an integer, roll is equal to 1. I just wrote that down quickly. Roll is less than or equal to 6 million. So we're going to increment frequency. Remember, frequency is an array. We're going to increment frequency sub. So we're looking at analyzing the index value for the frequency array. And the index, there's our angle bracket, and we have an expression. Now we have 1 plus random numbers dot next int with a scale value of 6. So random numbers dot next int will return an integer in the range 0 through 5. There's our scale up to 6. So this will return 0, 1, 2, 3, 4, or 5. And then we add 1 to that. One, 2, 1 plus 0 would be 1. 1 plus 1 would be 2. 1 plus 2 would be 3. So we're generating our face values. Our face values are 1 through 6. So now we have a frequency index 1 through 6, and we're going to increment that. So int roll 1, we're going to randomly generate an integer from 0 to 5. Let's say that random integer is 3. 0 through 5, we generated 3 as a random integer. We're going to add 1 to it. So 3 plus 1 would be 4. So I'm looking at incrementing frequency sub 4. Well, frequency sub 4 happened to be initialized to its integer value of 0 when we created the array. So now the value in frequency sub 4 is 0. We're going to increment it by 1. 0 plus 1 would be 1. So we have a count of a face value of 4 being generated once on our first roll of 6 million rolls. That's a one-statement body of the loop of the 4-roll iteration. So we'll go back to 4 int roll. Roll was incremented by 1, so roll is now 2. We're going to increment frequency sub, and we have an expression to calculate the index value. 1 plus random numbers dot next int, and we're scaling the range 6, which will return an integer 0 through 5. So it randomly generates an integer 0 through 5. So let's say it generates 2. Then our expression continues. Whatever random integer 0 through 5 is generated, we're going to add 1 to it. Plus 1 equals 3. And then we have resolved the index expression, and we end up with plus frequency 3. So we're going to increment the current value stored in index 3 of the frequency array. Well, we've initialized, when we created the array, the integer values to 0. So frequency sub 3 is currently default value of 0. If I increment it by 1, frequency 3 is 0 plus 1 at 1. So we've actually, in 2 rolls, simulated rolling a face value of 4 on the dice and counting that face value in our frequency array, and rolling a face value of 3 and counting that face value roll out of 6 million tosses. So as we continue to allow roll to increment by 1 up to 6 million, we will have kept a running accumulated frequency count of each time an individual face value was rolled on the die. So now we've simulated rolling the dice that many times. We want a system.out.print formatted, nicely columnized with some spacing of 10 spaces. I'm going to print the first string, and then in a space of 10, we're going to place the frequency string and a new line. So we're setting up our headers and column headings, I guess, for our output report. And then output each array element's value. For integer face equals 1, while face is less than frequency.length. Notice the semicolons. Then we're going to increment face. All right, let's look at that statement a little closer. for int face equals 1, while face is less than frequency.length. Frequency.length, every array, and this is an array by the name of frequency, every array knows its own length. Knows the number of compartments, the number of elements. When we create and declare a new array, every array, and frequency is declared to be an array, every array knows its own length. So that's an instance variable of the frequency array object. So we don't have to count or guess or determine. Every array already knows its own length. So we're going to traverse the integer array from 1, while face increments by 1 on each iteration, up to frequency.length. And the length of our array frequency is 7 compartments. Now we're going to traverse this array from frequency letting face equal 1. So we're starting here. Remember, we ignored, logically, we decided to ignore the first compartment, which is frequency sub 0. We're looking at a face value of 1 rolled on our dice for frequency sub 1. So face is equal to 1. It's going to iterate 1 to 2 to 3 to 4 to 5 to 6, while it iterates to 7, while that would be equal to frequency.length. This is a 7 compartment array. So we want to iterate from 1 through index 6, which is the 7th compartment, for a length of, an array length of 7. So we're going to iterate from 1 through 6. Face value will increase to 7. That determines that face is equal to frequency.length, so we would stop iteration of the 4 face iteration and continue to the next line. So we have to be careful when we are designing the program, and we made the decision that we're going to ignore, for a logical reason, frequency sub 0, then we would not want to assign face equal to 0 to check or use or process frequency sub 0's elements value. So it's a conscious decision, makes sense. We're going to ignore the 0 compartment. We're going to use indexes 1, 2, 3, 4, 5, 6 to represent our face values, face 1, face 2, face 3, face 4, face 5, face 6, which are possible rolls of our dice. But then we have to adjust our code as well to accommodate. So we want to iterate through the frequency array for face values 1 through 6. We don't want to look at the 7th index. We would be beyond our index values. We want to stay less than. The frequency length is 7. Face 6 is less than 7. So we will iterate from face 1 through face 6 with our subscripts for the frequency array. Now in the iteration of the 4, we have a single statement again. System.out.print formatted. We're going to print in a space of 4, the first string, face. And then we're going to print first string and space 4, and then we're going to print the integer value that's currently stored in frequency sub face. On the first iteration, face is equal to 1, so we're looking at what was the count stored for the number of times that a face value of 1 was rolled out of 6 million. So there'll be some value here. Frequency sub 1. We're going to print that value. We're going to return to the 4. Face increments by 1. Face is equal to 2. 2 is less than frequency dot length. I'm sorry. 2 is less than frequency dot length, so we will process the statement of the 4. System.out.print, we're going to print the formatted string, and then we're going to print the integer value frequency sub 2. And frequency sub 2 is storing the count of the number of times that a face value of 2 was rolled on our die out of 6 million rolls. Face increments to 3. We're going to test face is less than or equal to frequency dot length. 3 is less than frequency dot length, so we're going to print again in a formatted the face value, which is 3. We're going to print the frequency sub 3. Frequency sub 3 is going to house the number of times, the accumulated number of times that a face value of 3 was rolled. Let's skip up to face increments to 3, 4, 5, and face value is now 6. For face less than or equal to frequency, if face is 6, 6 is less than the frequency dot length. The length of this array is known as 7 when it was declared initially to be an integer array with 7 compartments, 0 through 6. 6 is less than 7, so we're going to process the statement of the 4. We're going to print formatted face, which is face 6, in columns, and then we're going to print the integer value frequency sub 6, and we will print the count for the number of times that a face value of 6 was displayed out of 6 million rolls. Face increments to 7. 4, we return to 4. 7 is less than frequency dot length. The length of frequency is 7. It was declared to be 7. 7 compartments, 0 through 6. 7 is not less than 7. 7 is equal to 7. So we exit the body of the 4. And exit main and exit class roll die. Let's see what happens when we run the program. Okay, I created a new project by the name of Figure 7-7, and then I added a new file and copied the text file into the editor. Then I did a file save all, and now I'm ready to test the program. So let's run the program. Takes a little bit to simulate running 6 million rolls. So we tossed our dice 6 million times, and we counted the number of times that a face value of 1 was rolled, and output that. In our column for the face value of 2, the frequency or the count that a face value of 2 was rolled is placed in the frequency column. Face value 3 was rolled 1,001,000 32 times. Face value of 4 was rolled 998,547 times. Face value 6 in its count, face value 5 and 6 in their count. Now, we said we rolled the die 6 million times, so I guess if I add the frequency counts, the number of times that each face was rolled, I should come up with 6 million. So adding 998,336 plus 1,000,444 plus 1,000,1032 plus 998,547 plus 1,000,823 plus 1,000,818. And sure enough, there's 100,000, 6 million. Now when we run the program again, this is going to have new counts for the simulation of rolling your die 6 million times. So let's see what happens when we roll our die again for 6 million times. So I'm going to run the program. It's simulating rolling my die 6 million times, and it's going to give a frequency count. For the number of times that each face was rolled out of 6 million rolls. So again, if you add your frequency count, you'll end up with 6 million attempts. And we've been able to count the number of times that each face was rolled. Now, some things to remember with this program. We declared our integer array with 7 compartments. 1, 2, 3, 4, 5, 6, 7. Remember your 0 offset. The first compartment of an array is array sub 0. Always. We declared our array to be 7 compartments, which allows us to include 1, 2, 3, 4, 5, 6 for our index values, which logically makes sense because we have on our dice face values of 1, 2, 3, 4, 5, 6. And we want to count the number of times that a face value of 1 was rolled, the number of times that a face value of 2. So we're associating face value 1 with frequency sub 1. Face value 2 with frequency sub 2. And that means that we're ignoring this first compartment, which actually lives in primary memory, frequency sub 0. So that makes sense. That's a logical plan. But I have to accommodate my code to match that logical plan. I'm declaring my new integer frequency array to have 7 compartments. That's 0 through 7 for my index values. When I roll the dice, I want to make sure that I start with a roll of 1, while roll is less than or equal to 6 million. And I want to make sure that I have a index value for frequency of my face values 1 through 6. So I'm using my angle brackets, and here we're going to have an expression to determine the index value. 1 plus random numbers dot next int 6. So that's my scaling value. I'm going to return a random number between 0 and 5. 0 and 5 up to 6, but not including 6. 0 through 5. And I'm going to add 1 to that for an ending value of 1 through 6. So when I get a random number 0 through 5, let's say 2, I add 1 to 2, I get 3, which is a value 1 through 6 for a face value of 3. I'm going to increment frequency sub 3, which simulates rolling of the dice face value 3. I'm going to increment frequency sub 3. It was 1, incrementing by 1. It'll be now 2 for a count of the face value rolled by the dice. So that should be clearer to you now. Random.nextInt scale factors and shift values, I think, are talked about actually in chapter 5. And then accommodating the logical ignoring of our frequency sub-0. When we output each array's element values, we need to iterate from a face value of compartment sub 1 through index 6. So we're iterating through the frequency array, but we're starting with face value 1, while face is less than or equal to the frequency length, which is 7. So that'll allow us to increment from 1, 2, 3, 4, 5, 6. When face is equal to 6, it's still less than frequency dot length of 7. We'll iterate the last time face increments. Face is now equal to 7. 7 is not less than frequency dot length, which is 7. So we do exit. So logically, in our design, we made a good plan to ignore frequency sub-0 and to match our die face values with the subscripts. But then your code has to be adjusted accordingly so that we don't accidentally process frequency sub-0, increment frequency sub-0, use frequency sub-0 in some math expression, which would cause some type of error. We want to just allow it to be declared, but ignore it in processing. All right, then we continue with shared code on page 254 and 255. Now on page 254, we are given the problem statement. 20 students were asked to rate on a scale of 1 to 5 the quality of food in the student cafeteria. With 1 being awful and 5 being excellent. Place the 20 responses in an integer array and determine the frequency of each rating. Now, students are rating the school cafeteria food with a value of 1 through 5. So the first response stored in a response array in compartment sub 0, so that's my index 0, the first response was 1. So the first student response that I determined in my stack of surveys was 1. In the responses array sub 1, the next student response rating from 1 through 5 was 2. I looked at the next survey, so I placed that response 1 through 5 in responses sub 2, and that student rated 5. There's 20 elements in the responses array for 20 student responses to be organized. So with 20 elements in this array, that takes me down to responses sub 19. Remember, 0 through 19 would give you 20 compartments, 20 elements in the responses array. So looking at our code, this is figure 7.8 on page 254, 255. Student.poll.java. It's public class student poll, class begin, class end, public static void main, begin and end. And then comment, student response array, more typically input at runtime. All right, it's trying to remind us that typically we might be capturing the student responses during execution of the program, but in this simulation we have gathered the responses of the students and we place those responses in our 20 compartment array. We are declaring an integer array by the name of responses, and responses is a reference pointing to an integer single array compartment with 20 0 through 19 indexes. And now this is a way to fill and assign each element in your array if it's known at the time you write the code, which we're trying to say in the comment. More typically, we'd be assigning the input of the array, the assignment of the array elements at runtime, capturing the input at runtime. But you can assign an array its element values using the brace, open and close. The first element is going to be assigned 1, comma, the second element assigned 2, comma. Third element, well, that's the third response that we received from students, and that particular student gave us a rating of 5. So now our array begins to look like our responses array in compartment 1, which is actually index 0. In the first compartment, that's responses sub 0. The first reply was 1. In a response sub 1, our rating is 2. Response sub 2, the rating is 5. Response sub 3, the rating was 4. Response sub 4, the rating was 3, and response sub 5, the rating was 5, and so on, up to response sub 19. Response sub 19 is 14. So response sub 19 is storing a value of 14. Now, 14 was not a valid response rating. A student should have reported a rating of 1, 2, 3, 4, or 5. 1 being awful and 5 being excellent. So a response rating of 14 is kind of out of bounds, and we're going to see what happens when we try to process that value. So we have the response integer array declared with a length of 20. And we use the assignment process with the braces to assign each element of the array its current rating value. Now we're declaring another integer array, int angle bracket, by the name of frequency equals a new object with a reference to that frequency array. It's an integer array with 6 compartments. That's index 0 through 5. Index 0 through 5. 0, 1, 2, 3, 4, 5 is 6 compartments. So our frequency array, frequency length of 6 looks like frequency sub 0, frequency sub 1, frequency sub 2, frequency sub 3, frequency sub 4, frequency sub 5. For 1, 2, 3, 4, 5, 6 elements. So frequency dot length, the frequency array knows its own length, so frequency dot length is 6. So frequency dot length would return 6. Now in our plan, we're going to once again ignore frequency sub 0. Logically, that makes sense because we're evaluating survey responses, and valid responses can be 1 through 5. So a student rating of 1 is going to associate to our frequency, our count of how many times was a rating of 1 given. A student rating of 2, we're going to keep count of the number of 2 ratings we received in our frequency array sub 2. And a rating of 3, we're going to keep track of the count of the ratings of 3 in frequency sub 3. And a student rating of 4, we're going to keep count in the frequency sub 4 compartment. And a student rating of 5, we're going to keep track of the count, the number of times that our students had a 5 rating in frequency sub 5. Designing the program, we're ignoring frequency sub 0. It makes sense. We're going to associate a student survey rating of 1 with frequency sub 1 through a student rating of 5. We're going to associate student rating of 5 with frequency sub 5. But doing that, we want to make sure that we don't inappropriately reference frequency sub 0 in our programming code. So for each answer, select responses element and use that value as frequency index to determine element to increment. So for int answer equals 0. Answer equals 0. While answer is less than responses dot length. Well, responses has a length of 20. So responses dot length, that actually is 20. Every array knows its own length. and we're going to increment answer on every iteration. So the first time through, answer is equal to 0. Now here's our try catch block. We're going to try, and the block braces are necessary. Even though there's only one statement, it is necessary that we have our try, open and close brace. We're going to try to increment frequency sub, so we're going to be processing an expression to get our index value. This statement increments the appropriate frequency count as determined by the value of responses sub-answer. Here's responses sub-answer, which is our response array sub-index. Well, the first time through, answer is equal to 0. So responses sub-0, we can look that up. Responses sub-0 is equal to 1. And in our code, we can observe that as well. When we declared the array, we also assigned the element values, and responses sub-0 has a value of 1. So responses sub-0, responses when answer is 0, responses sub-0 is equal to 1. I'll just pencil that there right now. Now we continue with increment frequency sub-1. Frequency sub-1. Well, frequency sub-1, when we initialize, when we declare a new array, if we don't initialize the values, it's initialized to 0. So frequency sub-1 is 0 plus 1. We're incrementing frequency sub-1 and assigning its current value to 1. So we have one student rating of 1 so far. Because that process successfully, there's no need to process catching an error. So we will bypass the catch. We're at the end of the 4. We go back to 4 answer, and answer increments by 1. So answer is now equal to 2. Two is less than 20, the current length of responses array. Responses.length returns the length of the responses array as an instance variable of the array object, responses array object. Every array knows its own length. 2 is less than 20, so we're going to process the 4 block. We're going to protect our statement under a try block. The braces are needed. Plus frequency index. We have an expression within to calculate the index. Responses sub answer. I'm just going to put that up here. Answer is 2. Responses sub 2 is responses sub 2 equal to 5. So responses sub 2 returns 5. We're going to increment frequency sub 5. Frequency sub 5 was initialized to 0, so 0 plus 1 is 1. We have one student rating of 5 accumulated in our frequency sub 5 array. That process successfully, so there's no need to catch an error. that we may have trapped by trying to execute this statement. So we go to the end of the for block, return, and answer is incremented to 3. And 4, and 5, and 6, and 7, and 18. Responses is a size of 20 for length. So let's go to 18 here. All right, so we're going back to the 4, and answers incremented to 18. 18 is less than 20. The responses dot length value, so we will iterate. We're going to try plus frequency sub responses sub answer. Answer is 18. Responses sub 18. The value stored in responses sub 18 is 2. So that returns 2. We need to increment frequency sub 2. Frequency sub 2 was initialized to 0, 0 plus increment value of 1 is 1. 0 plus 1 is 1. That was handled successfully, so there's no need to catch an error. So we go to the end of the 4, and answer is incremented to 19. 19 is less than responses dot length. We're going to try to process this statement. Plus frequency sub. We have an expression that we need to calculate. Responses sub answer, which is 19. Responses sub 19. Responses sub 19 is restoring 14. So 14 is returned. We're going to increment frequency sub 14. Frequency sub 14 does not exist. We've declared our frequency array to be a length of 6 with subscripts 0 through 5. There is no subscript 14. That's an error. Your program would need to halt and stop illogically. But we have this statement protected in a try block, and we're trying to execute it successfully, but we have trapped an error during execution. So we can try to program to recover from errors that occur during execution. When this is executed, the error is trapped. We catch the error as an array index out of bounds exception. We're going to test then. In the catch block, we're sent to the catch block because the try block has captured an error. We're going to try to handle it with the catch block as an array out of bounds exception. We're going to system.out print line the exception string, and that call E, that calls the toString method, and the toString method prints implicitly. We don't need to import anything. This is an explicit toString, and it converts java.lang.array index out of bounds exception to a string, and we're printing that java.array.index out of bounds exception. And then we can on a line, and then system.out print formatted, a little bit of spacing, responses sub %d is our answer, which is answer is currently 19. So answer 19, comma, equals %d responses sub answer. The value that responses sub 19 stores is 14, and a couple of new lines to present. 19, answer increments by 1. Answer is 20. 20 is not less than responses.length of 20. So our for loop exits, continues with the next statement following the for block. System.out, we print frequency and rating titles. And then we're outputting each array element's value as we iterate through the frequency array. Now our frequency array was declared with frequency sub 0 through sub 5. When we output our report, we don't want to illogically reference frequency sub 0 because we ignored that compartment and used only frequency sub 1 through 5. So we're getting ready to print out the values that are stored in frequency sub 1, the array keeping track of the rating options 1 through 5 returned by a survey to students. So for int rating equals 1, while rating is less than or equal to frequency.length, the length of frequency is 6. Each array knows its own length. We're going to allow rating to increment on each iteration. This is a one statement for, so we don't need the begin end braces. System.out.print formatted, we're going to print a formatted report for the integer value rating. Well, rating is 1, and frequency sub 1. Remember, that's going to be keeping an ongoing running count of the number of times that a student rated the cafeteria food at 1. We return for rating. Rating is incremented to 2. 2 is less than 6. We're going to output rating as a decimal. Rating is 2, frequency sub 2, and we're going to output frequency sub 2 stored value, which is a count of the number of times that 20 responses returned of student rating of 2, and so on. The end of main and the end of class. So let's try executing this program. Close all objects. I'm going to close my output window. File open, and I want to open figure 7.8 as a new project, and I have prepared a new file and copied that into my folder and the editor. So let's open that up. And this is studentpoll.java. Here the responses integer array is assigned its values within the code. So if any of those values change, you'd need to change the entry in the code line. This is a 20 compartment array, so responses.length is equal to 20. A 20 compartment array is responses sub 0 through responses sub 19. We have an integer array named frequency. It's equal to a new integer array with 6 compartments. 6 compartments is frequency sub 0 through frequency sub 5 for 6 compartments. Remember, the 0th index is always declared and assigned when we initialize an array. So let's run the program. And we find that on iteration through the responses array, we placed our increment of the frequency array subscripts, where responses sub answer needs to be executed as an expression to indicate the frequency subscript, and responses sub 19 has a value 14. So when we try to increment frequency sub 14, frequency sub 14 does not exist. The length of our frequency array is 6 compartments, 0 through 5. So frequency sub 14 does not exist. And at runtime, we want to protect for an array perhaps being out of bounds. So we've placed our increment frequency statement within a try block. Now you always need the braces in a try block, even if it's one statement. So we have our try open and try close. And as long as your statement or statements within your try block execute successfully, there's no error exception. If no error occurs, we continue on, and the catch and error is irrelevant. In our case, trying to increment frequency sub 14 is an array index out of bounds exception. That's an error that we can trap. So we're going to catch that error, array index out of bounds exception error, and in the catch, we're catching the error and handling it now during runtime. We need a catch begin and end block. In this case, we have several statements to process. System.out.println error, which invokes an implicit two-string method, and that prints the associated array index out of bounds exception. The E, it prints this right here. So on output, we are now printing the caught array index out of bounds exception error. That is an implicit two-string, so we implicitly inherit that from java.lang. So it prints java.lang.array index out of bounds exception : Next statement, system.out.printf. We have a quoted responses sub d. That's a integer value. So responses is printed. Angle bracket open. Answer is sub 19. And there's your closing angle bracket. A space equals %d. Responses sub 19, and responses sub 19 stores the value 14. So we've kind of documented that an array index out of bounds occurs. The array index value, which is out of bounds, is 14, and we were processing at the time our responses array sub 19, where responses sub 19 was storing a value, integer value of 14. Now, that all happened at runtime. The error was trapped. Our catch processed the error, output some information regarding the error. We're at the end of the catch block. We're at the end of 4. That's when answer is incremented to 20. Answer is not less than 20, it's equal to 20. Makes it false test, so we exit the 4 iteration, the 4 body, and we're at outputting our column headings, and then processing the frequency array to get the count, the number of times each student, the number of times that students' ratings were 1, 2, 3, 4, or 5. So print, we have 4 int rating equals 1, and that's where we're setting rating equal to 1, not 0, because frequency sub 0 does exist in memory. We are electing to ignore frequency sub 0, so we don't want to initialize rating to 0. We're going to iterate rating from 1 to 5 to simulate our frequency sub 1, sub 2, sub 3, sub 4, sub 5, where we have stored the count. So rating 1, rating is less than frequency.length. Frequency.length is 6. System.out print line, we're printing nice and neat the integer value of rating, which is 1. And frequency sub rating, frequency sub 1 had a count of 3. So 3 students returned a rating of 1. It's a single statement for, so we return rating is incremented to 2. 2 is less than frequency length, which is 6. Output formatted, rating is 2. Output the count in frequency sub 2, and 4 students had a rating of 2. And let's test when frequency is, rating is 5. Rating is 5. 5 is less than 6, so we're going to output rating, which is 5. Frequency sub 5 had stored a count value of 2. 2 students returned a rating of 5. We return rating is incremented to 6, and 6 is not less than the frequency sub length. Frequency has a length of 6 elements, 0 through 5. 6 is not less than 6, it's equal to 6, so that is a false test, and we exit the 4, exit main, and exit the class. So let's run this again. Our data, it remains the same. We didn't change any responses, although you could go in and change these responses to values 1 through 5. You could have an earlier exception if you wanted. So test by changing this data to get an example of a different output. All right, that completes the shared code for Chapter 7, sharing Figure 7-7 and Figure 7-8. Both files were shared with you via your .live account, So look in your email for the solution codes to the shared files, and you can simply create a new folder and add a new file, and create a new project in NetBeans and add a new file, copy and paste the sample file, and it is ready to go to run and execute and test and debug and try different values so that you can get an idea of how the program executes. So some very important concepts regarding the use of arrays. Arrays allow us to have a single name to reference multiple elements of stored data. All right, thank you very much.